Hi, welcome back. This is Professor Ridge and today's lesson on section 5.5, solving exponential equations and logarithmic equations. So our first property, base exponent property, says for any a greater than 0 and a not equal to 1, the equation a to the x equals a to the y is equivalent to x equals y. Alright, so we're going to use this to solve some exponential equations. Okay, so if we have an equation 2 to the third equals 2 to the x plus 3, the only way the left and right side can be equal to each other, since they have the same bases, the exponents have to be equal. So we drop the bases and say 3 equals x plus 3. Okay? So in this case, and then we solve that. So basically you're going to drop the bases, so 3 equals x plus 3. We're going to solve for x, so x equals 0. Now let's try another one. So if I had 5 to the 3x equals 5 to the x plus 8. And again, if the bases are the same, the only way that the left and right expressions can be equal to each other if the exponents are equal. So we just drop the bases and say 3x equals x plus 8. Now solve this equation. So we get 2x equals 8. Divide both sides by 2. X equals 4. Okay, so this one's a little bit harder because notice when you first look at it, 4 to the 3x minus 5 equals 16. You can't, you know, at first glance you don't think about this property, but the idea is, can you write 16 as a power of 4? And the answer is yes. You can write it as 4 squared. And so now we both have the same, both sides have the same base, 4, so we can drop the bases and say, well, then the exponents must be equal to each other. Okay, now solve this equation. So we have 3x equals 7, divide by 3. X equals 7/3. And we are done. Alright, and then this one a tiny bit harder than that. And again, at first glance you don't think you can, you know, we got 4 to 2x plus 5 equals 32. And you can't write 32 as a power of 4, I mean, easily with nice numbers. But both of these can be written as a power of 2. So what I'm going to do is rewrite it as powers of 2. And now I can drop the bases and get 2x plus 5 equals 5. And then I can continue there. So that's 0, so I get 0. Alright, so property of logarithmic equality. For any m greater than 0, n greater than 0, a greater than 0, and a not equal to 1, the log base a of m equals log base a of n is equivalent to m equals n. So if we have one logarithm on both sides of the equation and the same base, then you can drop the logarithms and say the numbers inside have to be equal to each other. So the only way these two expressions are equal to each other is the numbers inside are equal to each other. So an example, if we have log base 8 of 2x equals log base 8 of 5x minus 2, you can, since they're both log base 8, the only way these can be equal to each other if the numbers inside are equal to each other. So we drop the logs and just write the numbers inside are equal to each other. And then you solve that. So subtract 5x. So we get negative 3x equals negative 2. So x equals 2/3. Okay, so another way we can use the property of logarithmic equality is the other direction. So if we started out with an equation, 5 to the x equals 30, so 5x is the m and 30 is the n, I can choose, put log in front of both sides, and you can choose whatever base you want. So we can choose base 5, and then we know from our inverse rules log base 5 of 5x is just x, and then this is our answer, and we're done. Now if we want to approximate it, use change of base formula. So x equals log of 30 divided by log of 5, which is going to be about 2.1133. Now, alternate way to do this, if you're going to approximate the answer, is just go ahead and put LOG, put log in front of both sides, or ln in front of both sides, either one. Okay, so let me show you what I'm talking about. So if I have 5x equals 30, I'm going to use ln this time, because that's typically the one I would use. So you put ln in front of both sides, or the common log, log, doesn't matter. Just pick one and do it to both sides, golden rule, right? So now we're going to use the power rule. We're going to take this x and bring it out in front. So x times ln of 5 equals ln of 30. And we're solving for x, so now we're going to divide both sides by ln of 5. So x equals ln of 30 divided by ln of 5, and you can approximate your calculator and you'll get the same answer. Okay, so it's up to you which way you do it. And actually I'm going to give you one more way to think of it. So here's the alternate way, number 2. Okay, so the other way to do it is, if you get an exponential equation, you get a base to a power equals a number. Okay, so if you just have a basic exponential equation, convert it to log form. So remember, we're going to start with the base, log base 5, logarithm equals an exponent, exponent's x, and the 30 is the only number left over, it goes there. And that's it, that's your answer again, that's the exact answer. And then you do just like we did above. If you want to approximate it, you use change of base formula and get log of 30 over log of 5, which is 2.1133. Okay? So any of those methods would work. Typically, when I do these problems, I do it alternate way number 2 for simple stuff like that. But the one I use most common, the one I do the most is the first alternate way, where you put ln in front of both sides. And that will work for everything. Okay, let's do another one. So again, you can do it any of the 3 ways that I showed you above. Typically, again, I do just put the ln in front of both sides. Oops, ln of 40, and then bring the x out in front. ln 2, ln 40, and then you're going to divide by ln of 2. So x equals, well, about, x is about, and punch that in your calculator and you should get 5.322. Okay, so on this one, again, I'm going to put ln in front of both sides. Now, bring the power out in front, so x plus 2, ln of 5, 1 minus x, and put it in parentheses. Now, what confuses most people on this problem is this ln 5, that's just a number. In fact, I can punch it in my calculator and approximate it, and that's 1.60943. Okay, so if you had this number out in front or outside of parentheses, it means times. So you're going to distribute it, and you're going to get x ln of 5. So again, that's 1.6, about 1.6. So that's 1.6x. This looks funny if you're not used to logarithms. And then we get 2 ln 5 because we're distributing. 1 times ln 4 is ln 4 minus x ln 4. Now from here, again, the ln 5 is just a number, ln 4 is just a number. So what I want to do is get all the x terms on the same side. So I'm going to add ln 4 to both sides. So I have x ln 5 plus x ln 4 plus 2 ln 5 equals ln 4. I'm going to subtract the 2 ln 5 from both sides. So we got x ln 5 plus x ln 4 equals ln 4 minus 2 ln 5. Okay, now I got both x terms on the left side, so I want to factor that x out and put in parentheses what's left over. And then I'm going to divide by the parentheses. So x equals ln 4 minus 2 ln 5 divided by the parenthesis ln 5 plus ln 4. Now we can use our properties and make this look a little nicer, or you just punch it in your calculator like that. I prefer just to leave it like that, punch it in my calculator. It takes some practice. When you punch it in your calculator, you need to either work out the bottom and write down as many decimal places as you can, because you don't want rounding error. You're going to have a little bit of rounding error, but you want it far enough out that if I ask you to round it 3 places, that the third digit's going to be the right place. I mean the right number. So you want to carry a lot of digits. So I just leave it in my calculator actually. So you're going to hit ln 4 minus 2 ln 5, hit equals, and then divided by, and then use the parentheses, ln 5 plus ln 4, close parentheses, hit equals, and you should get negative 0.612. If I have you round it to 3 places. Alright, let's try another one of those just to get some, make sure you got it here. So solve 2 to the x plus 1 equals 5 to the 2x. So again, since the bases aren't the same, I can't use the easy way, so I just put in ln in front of both sides. Bring the power out in front of each ln. And 2x is just one term, so I don't need to put parentheses around it. So I want to distribute the ln2 on the right side, or the left side. So it's x ln 2 plus 1 ln 2, which is just ln 2. 2x ln 5. Now let's get all the x terms on one side. So we got ln 2 equals 2x ln 5 minus x ln 2. Factor out the x, and then you're left with 2 ln 5 minus ln 2. And then you're going to divide by the parenthesis. So we get ln 2 divided by the parenthesis 2 ln 5 minus ln 2. And punch that in your calculator, and you should get, so x is going to be about 2 or 0.274. Okay, so again, this is the exact answer. Now I can clean it up, make it look a little better, because on the bottom, 2 ln 5, that's the same thing as ln of 25, because you bring the 2 inside as a power, and then you're going to divide by the 2. So it'll be ln of 25 halves, if you want it to look. So no. ln 2 over 2 ln 5 minus ln 2 is equal to ln 2 over ln of parentheses 50, or not 50, 25 over 2. So that might be a little easier to write, punch in your calculator, and you'll get the same answer. Typically I don't do that, I just punch it all in just the way it is without combining it. Okay, so let's convert. Now, one technique, right, is if you have 1 log equals 1 log, you drop the logs. We just talked about that. Another one is if you have 1 log equals a number, then you're going to then convert it to exponential form. So remember, so we got 1 log, so log base 2 of x equals -3. 1 log equals a number. So we start with the base. We're going to convert it to exponential form. Log equals exponent. Log equals exponent. So -3 is the exponent. See, now we're done. Just simplify that. So x equals, remember, negative exponent's 1 over. It's the reciprocal. So 2 cubed is 8. So x equals 1/8. All right, so again, if you have 1 log, natural log of x equals -2. If you have 1 log equals a number, we're going to start with the base. The base is e. Log equals exponent. Exponent's -2. And that's your answer. So it's 1 over, so x equals 1 over e squared. And again, that's an exact answer. If I approximate it, I can punch that in my calculator. Okay, now let's look at log base 5 of 8 minus 7x equals 3. So again, it's 1 log equals a number. So we start with the base is 5. Log equals an exponent. 3 is the exponent. And the number inside goes over here. So now we just have a nice linear equation. So solve it. So I'm going to get x by itself. I'm going to divide by -7. So x equals -1/17. Now, one thing when you're solving logarithmic equations, or provisions here is this number inside the domain of this function is 8 minus 7x has to be greater than 0. So we have to keep that in mind when we're working this out. So we got -7x when you divide by a negative, remember it flips the inequality sign. So if our solution to this problem is not in the domain, then you got to throw it out and say there's no solution. So there's 2 ways you can do it. You can figure out the domain and then see if your answer is in the domain, or just plug it back into the problem and make sure it works. So either way. So you got to be conscious of the domain and make sure that your answer is in the domain, meaning you're allowed to use it. If it's not, you throw it out, no solution. Or you can just plug it into the problem and check it to make sure it works. If it works, great, that's the solution. If it doesn't work, throw it out, no solution. So hopefully you got that. Okay. Okay, so let's try this problem. Now look, we have two expressions with logarithms. Log base 2 of x plus 1 plus log base 2 of x minus 1 equals 3. So the two techniques that we have is we want 1 log equals 1 log, and then you could drop the logs. I don't have that. Another one is to get 1 log equals a number. So do we have any rules that can make that side, combine it and make it 1 log? The answer is yes. We spent a section learning how to pull these apart and put them together. So if you're adding two logarithms, you multiply the numbers inside. And now we have 1 log equals a number. So I'm going to convert it. 2 to the 3 equals x plus 1 times x minus 1. And then just simplify this. X squared minus 1. Because I FOIL it, right? That's a difference of squares. Alright, this is a quadratic equation, so we're going to add 1. There's no middle term, so I can use the square root principle. X equals plus or minus 3, but remember what I said? That you have to know the domain. So x plus 1 has to be greater than 0, and x minus 1 has to be greater than 0. So you take the most restrictive one out of those two. So x has to be greater than -1, and x has to be greater than 1. So this collapses down into just x is greater than 1. And you can see that x equals -3 is no good, so we just get the positive 3. Again, or you can just check it, plug them both in and see. You can see if you plugged in -3, so x equals -3, when you try to punch this into your calculator, you're going to get an error message, right? You can't do, that's undefined, so you can't use x equals -3. Okay, it's no good. So you're going to throw x equals -3 out. If you plug in positive 3, you get, it's fine, no problem. And it works. Okay, so again, we want to make it 1 log on both sides, or 1 log equals a number. So I'm going to try to make this 1 logarithm, so I can bring the 2 up as a power. And then I'm going to divide. So ln of x squared divided by 5 equals ln of x plus 10. So now I got 1 log on both sides, they're the same base, so I can drop the bases. So x squared must be x plus 10. I'm going to think of it like that. I'm going to cross multiply. So x squared equals 5x plus 50. This is a quadratic equation. So how are we going to solve this one? We can use quadratic formula, or we can do the get it equal to 0 factor, and then set each factor equal to 0. So let's good review. And solve. So we got x squared minus 5x minus 50 equals 0. Factor 50, subtract the 5. So that's 10 and 5. Bigger one's minus, signs are different. And then we get x minus 10 equals 0, x plus 5 equals 0, so x equals 10, or x equals -5. Now again, we got to think about the domain. If we see that in the very first one, ln of x, so our domain has to be x has to be greater than 0, and x plus 10 has to be greater than 0. So the most restrictive one is x is greater than 0. Okay? So this one is no good. X equals -5 is no good. So when you put it in, you'll get an undefined term, which is no good. So we just have x equals 10. And again, if you want to check it, plug it in. work it out, you should get the same number on both sides. Okay, so if I ask you to solve this equation, so let's do an exponential one. The goal is you have to have one log equals a number. That's one of the techniques. So you want to get rid of this 5 first. So you got to divide by the 5 first. Then you have e to the 3x equals 15. And now you can do ln in front of both sides. Remember, ln of e is just the power. So we get 3x equals ln 15. And then you're going to divide both sides by 3. So x equals ln 15 divided by 3, which is about 0.903. And then same thing, if I had a number out in front of a logarithm, so 6 log base 2 x plus 3 of say 24, what we're going to do is you got to get rid of this 6 first. So divide both sides by 6. So log base 2 of x plus 3 equals 4. Now you got one log equals a number, so you convert it to exponential form. 2 to the 4 equals x plus 3, which is, no, that's not 8. 2, 4, 8, 16. 16 equals x plus 3. Subtract 3. X equals 13. Alright, so one more problem. And this one is very tricky. This one, most people won't get it until someone shows them the trick. So if I said solve e to the x minus 6e to the negative x equals 1, the idea is you're going to first clear the fraction. So multiply everything by, well, it's not a fraction yet. E to the negative x is e over, goes to the bottom. So see, now I want to clear the fraction. So we're going to clear the fraction. You're going to multiply everything by e to the x on both sides. So we're going to do e to the x, e to the x. So we're going to end e to the x times e to the x is e to the 2x, because you're going to get, right, they have the same base, so you add the exponents. X plus x is 2x. Now when you distribute it to the second term there, the e to the x's cancel, because you got e to the x on top, e to the x on bottom. They cancel. That was the whole point. We want to clear that fraction. It goes e to the x. Now, believe it or not, this behaves like a quadratic equation. So what I do is I subtract e to the x from both sides, and I do my u substitution. We're going to let u equal that middle term e to the x. So we get e to the 2x is same thing as e to the x in parentheses squared by the power rule. So that's going to be u squared minus u minus 6 equals 0. And then we solve for u. So we factor it. Factor 6 subtract to 1 is 3 and 2. Negative, positive. And then u is equal to, or you're going to set each equal to 0. So u equals 3 or u equals negative 2. And then you're going to put e to the x in there, because we're solving for x. And you're going to solve both of those. So e to the x equals 3, which is the same thing as you're going to do ln on both sides, so, or convert it to the net. So it's ln 3 times e to the x. So e to the x equals 3 minus e to the 2x. So e to the x equals 3 minus e to the 2x. So e to the x equals 3 minus e to the 2x. So e to the x equals 3 minus e to the 2x. So e to the x equals 3 minus e to the 2x. So e to the x equals 3 minus e to the 2x. So e to the x equals 3 minus e to the 2x. So e to the x equals 3 minus e to the 2x. So e to the x equals 3 minus e to the 2x. So e to the x equals 3 minus e to the 2x. So e to the x equals 3 minus e to the 2x. So e to the x equals 3 minus e to the 2x. So e to the x equals 3 minus e to the 2x. So e to the x equals 3 minus e to the 2x. So e to the x equals 3 minus e to the 2x. So e to the x equals 3 minus e to the 2x. So e to the x equals 3 minus e to the 2x. So e to the x equals 3 minus e to the of 3 equals x. And this one, if you do ln on both sides, well, that doesn't make sense. Ln of negative 2 equals x. Can't do that one. So ln of 3 is our answer. Alright, so that concludes the lesson for 5.5. Go to My Math Lab, do your exercises there, and I'll see you next time.